Okay, we're back. So, checking our biases. We've all got them. As the quote says, the first principle is that you must not fool yourself, and you are the easiest person to fool. Because you know exactly what you want to hear, right? So, we're going to go over not every cognitive bias because there are so many, but just some of the more common ones that we encounter in our daily lives and we may encounter when doing research as well. So, of course, we've gone over confirmation bias, actively seeking information that justifies existing beliefs and ignoring or dismissing information that conflicts with your beliefs. And this is kind of under the confirmation bias umbrella, but there's also a phenomenon that human beings exhibit called selective perception. They did an experiment where they had people watching a football game and then they asked them about the game afterward, and the researchers noticed that people were really good at spotting infractions by the other football team, the opposing team, but they did not see the ones made by people on their own team, by the players on their own team. Like, not saw them and didn't bring them up, but straight up did not see them. Okay, but they were really good at spotting the ones on the other team. So this is something we all do, and it's basically, yeah, having a selective perception, only really seeing the things that we want to see versus the things that we don't want to see. We do it all the time. Anchoring fallacy. So, this is the fallacy of being over reliant on the first piece of information you get. People do that all the time, and it might be laziness, or it might just be there's just something comforting about that first piece of information you get. So, this is why we need to have multiple sources, because we need to make sure that we're not over relying on the first thing that comes our way. We need to fact check it against other sources and also try not to let it skew what we look for from that point onward, right? We don't go in with confirmation bias again. We don't want to just find things that confirm what the first source said, right? Anchoring fallacy. Go with the first train that comes your way. Sunk cost fallacy. So, this one, I don't know so much about research, but I mean, I guess it depends on what you're arguing on. But the sunk cost fallacy, people do this all the time. It's the fallacy of clinging to things that have already cost you something, right? This idea that, okay, I've already put in the time, or I've already put in the money, or I've already put in the effort, or whatever. So I should keep doing that, even if it's a bad idea or a bad bargain or a bad whatever. Like, people do this in relationships too, I think. Well, I've already done, this many years of my life with someone, so I might as well just keep at it, even if it's not working. So, yeah, there's also the that old saying, throwing good money after bad. People do that all the time because they're like, well, I already spent money on it, so it's important to me now. I'm invested and I can't walk away from it. Well, you might just be throwing more good money after bad. Clustering effect. Okay, so this is the fallacy of people seeing patterns where there are no patterns. So we talk in the logical fallacies presentation about post hoc ergo propter hoc. After this, therefore, because of this. The idea that there's the order of events determines causation when they might not be related at all. This happens a lot too with like things happening together. Correlation. So correlate. If let me do my little pen here. If A increased and B also increased, then A and B must be related. There must be a causal relationship between them. Well, that's not necessarily true. There's all kinds of things that just happen together that have nothing to do with each other. And so I'm going to leave this presentation and show you something kind of neat. It's I think, pretty amazing website. It's hilarious and teaches a good lesson. It's called Spurious Correlations. Let's check it out. No, I don't want to keep them. All right, we're going to leave. I got to show you this thing. So this is Spurious Correlations. Okay, it's really cool. So this is all real information. This is all real data. All right. This is a chart showing the correlation between the United States spending on science, space, and technology and suicides by hanging, strangulation, and suffocation. So we know that those two things have nothing to do with each other. But I mean, look at that graph though. Like, The correlation is super strong, 99.79%. That's nuts. Wow. So they got to be related, right? Nope. Number of people who drowned by falling into a pool correlates with the films Nicolas Cage appeared in. Okay. Per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. Oh my gosh, that sounds horrible. We clearly need to stop eating so much cheese. The divorce rate in Maine correlates with the per capita consumption of margarine. Okay, so clearly we need to stop eating so much margarine, not because it's gross, but because we need to help these poor people in Maine keep their marriages together. Age of Miss America correlates with murders by steam, hot vapors, and hot objects. Total revenue generated by arcade. I mean, you get the idea, right? So there's tons of them, and they have nothing to do with each. Oh, I love this one. People who drown after falling out of a fishing boat in the marriage rate in Kentucky. Oh my gosh. So they're all pretty morbid, but not all of them. But the point I'm trying to make is, all right, when you got this label on the top of the graph, you're like, okay, it's clearly just a huge coincidence. But that's because we don't want to find a relationship between those things. We're not invested in that in any way. But if we wanted to see a causal relationship between the line in red and the line in black, if we wanted to see a connection, this would be very, very compelling evidence, right? If we swapped out the labels with something like vaccinations and autism diagnoses, well, then this would be like, that's it. See, it proves it, right? When it could just be a total coincidence, right? So it's just because things happen together doesn't mean that they're related, even though human beings are constantly trying to prove that, they are. We like to see patterns. We don't like chaos. All right, so we're back to that. We like consistency, even if it's ones that we made up in our own minds. All right, so clustering effect, right? If we see things together, we assume they're related. Placebo effect. I'm sure y'all have heard of that before, but yeah, it's really powerful. Like if people believe that they're taking medicine, then it can actually make them feel better, whether it's medicine or not. Now, this doesn't work on things like viruses, right? Or broken bones, right? If you believe that elderberry syrup is as good, that's my mother-in-law's really into that. If you believe that that's just as good as a flu shot, it's doesn't matter, right? Like the virus doesn't care whether you believe that or not. But for some things like pain relief, placebos are actually quite effective because the mind is very powerful. You can actually release your own painkillers from your brain, right? If your brain thinks that it's been given medicine to ease pain, then you will probably feel less pain, right? This is why they have to do double-blind trials when they do drug studies, because the placebo effect is so strong. Double blind means that not only is the person receiving the medicine not sure whether they're getting a placebo or real medicine, but the person administering it doesn't know whether they're getting the real thing or the placebo. Because it turns out if the person administering it knows whether it's fake or real, their subtle behaviors can influence, right, the outcome, because the other person can pick up on, okay, this isn't real or this is real, right? They can't know either, right? It's pretty crazy. So the placebo effect clearly impacts others too, even if they're not the one taking it. All right, backfire effect. So this happens when your core beliefs are challenged, and in challenging them, it actually can cause you to believe in them even more strongly. So it backfires, right? And this is why we have to approach things gently, because, and get our elephants together, because yeah, otherwise it can backfire. Fundamental attribution error. This is huge, okay? Fundamental attribution error is when we judge, so everyone does this, right? We judge other people on their character. If they do something stupid or mean or wrong or rude or whatever, we chalk that up to being part of a flaw in their character. But we judge ourselves and our behaviors on the situation, right? Well, I had to do that, or it's not my fault because, or so think about it when you're driving, right? We do this all the time. If someone cuts you off or somebody does something rude while driving, you assume it's because that person's a jerk, right? But if you have to do something kind of crazy or rude while driving, which we all have, it's because your situation is such that you're running late or whatever. right? But nobody else knows that, and they think you're a jerk or crazy or just a bad driver, right? So we all do that. When it comes to other people, it's because it's part of it's a flaw in their character. When it comes to ourselves, it's a flaw in our situations forcing us to act the way we are. So just know that about yourself and myself and all people, okay? And then, okay, before you say, but knowledge is always good, how can it be a curse? It's a curse when you understand something really well, you tend to presume that it is obvious to everyone else. So as an instructor, I run into this all the time. Okay. I think things are obvious when they are clearly not obvious, right? And that's because I've been doing this for so long that I'm like, okay, well, I mean, that goes without saying. Well, maybe it doesn't go without saying. So you just have to remember, and this is where like providing adequate background information and context leading up to your thesis statement is so important, because by the time you're writing the paper, you know so much more than the rest of us do about your topic that you just kind of assume that everybody's up to speed on what the controversy is and what's at stake and who's involved and all this kind of stuff, when we probably don't. So be gentle with us, take us by the hand, make sure you get us all filled in before going into the particulars. Otherwise, yeah, the whole thing is kind of lost. Declinism. So this is the fallacy, the cognitive bias of remembering the past as better than it was and expecting the future to be worse than it will likely be. Yeah, let that sink in. Like, you see it all the time, right? Maybe you're like that. I see it all the time. People, there's this kind of like golden halo over an abstract past that people like they seem to forget all kinds of things about the past, and they look back on it as like somehow better and more moral and more upstanding and more structured and easier, and I don't know, all these things that the past clearly was not. So yeah, things are super weird right now, obviously, but things, I mean, historically speaking, if you look back in the like we're okay. We're doing this right now. I mean, this is amazing. This is a miracle that we can do this right now, despite the fact that we've got a global pandemic. Like, no other people in history have been able to communicate the way that we're continuing to communicate and move forward in spite of the situation. So, yeah, it's tempting to look back on the past as being better than the present, and that the future is inevitably going to be worse. But that in itself is a bias, right? And yeah. So a best practice as a skeptic is to always think of your ideas and your beliefs as software that you are actively trying to find problems with, rather than things to be defended, right? Actively trying to find problems with. Poke around, poke at it, right? Not just other people's, but yourselves too. It's good for you. So that brings us to the smell test. So we're going to do an actual kind of more interactive version of this in our Collaborate session. I'm going to give y'all a TED Talk to watch, and we're going to get together in the Collaborate session, and we're going to put it to the smell test, because that's what we'd normally do in a class session, and it's a lot of fun, and it's interesting because everyone's biases come roaring to the surface. But it's good. It's a good exercise. But as we know from reading the article, the smell test, right? Smell stands for source, right? So who wrote this source and what qualifies them? What are their credentials? What is this person's motivation for providing the source? What kind of evidence are they using to back up what they're saying? What is their use of logic or logical fallacies if it's not good? And then this can be just as important as what they tell us, is like, what is not being talked about? What is being left out here from the picture that needs to be addressed that isn't? Okay. So I've got a little quickie real life example here. This is actually, this got put up twice by two different people in the same day on Facebook. I know a lot of y'all are too young and you're not on Facebook because it's for us oldies, but whatever. I'm sure it got around on Instagram too. It doesn't matter. Who knows? So this got put up. I saw it twice in the same day, and I was like, "Oh, okay." And this is why I'm such a pill to people on social media, because I of course feel the need to like be like, well, hold up. So this is what it said. And we're gonna put it to smell test real quick. So risks of being diagnosed with cancer in the year 1900, the risk was 1 in 30. 1980, 1 in 5. 1990, 1 in 4. 1995, 1 in 3. The year 2000, 1 in 2. We are doing something fundamentally wrong. Let's start with your plate. Okay, so let's start with the S. Okay, the honestly, that's just a big question mark. I tried looking up, I actually reverse image searched. I tried looking up the origins of this meme, and I cannot find it anywhere. The only other place I was able to find it was the exact same information, but this time it was over a picture of a kid who was bald from cancer treatments. Yeah. And it was for some raw food, like raw foodist. Yeah, they're a thing. Raw foodist website, like trying to get people to switch to a raw food diet. So yikes, right? Because that takes us to the motivation. This is clearly trying to freak people out. People see cancer and they're like, "Oh my goodness." But there are a lot of problems here with the phrasing. Let's start with the word diagnosed. So, diagnosis does not mean death. If anything, like it's going to you're more likely to live if you get diagnosed and it can be treated, right? So, that right there is a big problem, because this is assuming, this is getting everybody to be like they see a skull and crossbones as soon as they see the word cancer, right? When diagnosis does not equal death, it equals life, because you're much more likely to survive it, right? You can get treatment. So thinking about that going forward, right? And then it's like risk of being diagnosed. That the word risk is supposed to scare us too. So clearly the motive here is to freak people out and to make us feel bad. Let's start with we are doing something wrong. Start with your plate, right? Change your ways, right? That's what I'm seeing here. Let's look at the evidence. Okay, so if you have not seen that video I posted about how to spot a misleading graph, go watch that, because this is such a good example. It doesn't show us a graph, but it doesn't have to, because we're imagining one, right? We're imagining something that looks like this, right? We're imagining something that looks like that. But that, if we actually plotted it as a graph, that is not what we'd see, right? The X and Y axis. All right, well, let's do it. Okay, so if this is, let me go back to a pen. Right? If you're a graph person, this is your time to shine. If you're a math person, come get it, right? So if this is time, okay, and this is 1900, and this is 2000, right? That's 1,000. It's not 1,000 years. It's 100 years. Oh my gosh, what's wrong with me? 100 years. But then, okay, look at the numbers though. What do you see? It's a huge jump, right? It goes straight from 1900 to 1980. Let's say over here. All right, we'd have to do like 10-year increments to really make it, legit. But you're like, look at her garbage graph. Hey, you try to do this with a little stylus on a tablet. See how good yours looks. Anyway, so if this is 1980, okay, which that actually might be pretty close. Okay, so we went straight from 1900 to 1980, but oh my gosh, 80 years? Like that is such a huge jump. And then it goes straight from that to 90, and then from that to 95, right? So it's like skewing the numbers. So really all we're looking at is like the jump here, right, is in this tiny little time frame. If you stretch it out, it doesn't go real fast. It's a much slower progression. But also, let's take a second to talk about, like, okay, we go from 30 to 5 in an 80-year time span, but like, oh my gosh, what do you think the medical capabilities were in the year 1900, particularly when it came to diagnosing cancer? I mean, probably not that great. Like by the time they could tell you had it, like a tumor or whatever, you're probably close to dead, right? Now we have much, much better, more sophisticated technologies for cancer screening. So of course, the diagnosis rate is going to go up because just because fewer people were diagnosed in the year 1900, this is assuming any of this stuff is correct, by the way, just because fewer people were diagnosed, which we don't know, in 1900 doesn't mean fewer people had cancer. It just means we didn't know about it, right? It's like saying radio waves didn't exist until we invented radio waves, or until we invented radios. They did. They were always here. We just didn't have any way to detect them. So it was still there. We just didn't know about it. Okay. But another thing we got to take into account here is that, okay, diagnosis rates, again, assuming any of this stuff is true, diagnosis rates have increased. Not a bad thing. But you know what else has increased? Survival rates. Cancer survival rates have done nothing but gone up because of the better diagnosis technology. All right, so there's that too. There's also the fact that, okay, of course, the year 2000 was 20 years ago. So by this logic, we should all have cancer, right? But another thing has increased over the last 100 years, and it's lifespan. Okay. And the truth of the matter is that every year after 50, your likelihood of developing certain cancers increases. So that's if the average person lives to, 75, 80 years old, that's 25, 30 years of their life in which they're and every year, goes up, every decade it goes up. Yeah, if you've got people living longer, right? If life expectancy goes up, then understandably the rates of diagnosis for cancer are going to go up too. That's the flip side of that coin. Okay? But again, so have survival rates. So that's the thing that's being left out, right? Things like lifespan, things like survival rates, all that kind of stuff. Okay. So clearly the motivation here is to freak people out and to make them feel bad, to make them feel like they deserve what they get because of their bad dietary choices, right? It says we are doing something fundamentally wrong. Let's start with your plate. The logic here is that food or bad food choices equals cancer because diagnosis rates have gone up. And I don't know, the connection to food is pretty abstract here. I'm not really sure what it's supposed to be, but the thing is that there's another fallacy. It's called the Barnum fallacy. P.T. Barnum. It's this fallacy of filling in the blanks, of giving something vague enough that people will fill in the blanks themselves. So what people do when they see this is they think about all the things that they feel like are wrong and bad about their diet, and they're filling in those blanks for you or for whoever made this. They don't have to make the connection. Everyone's making the connection on their own based on what they're already concerned about and what they already feel bad about with their diets. It's pretty unscrupulous behavior, if you ask me. Okay, so that was a lot, but we'll do this. We'll do one for realsies with that TED Talk video. I'm really excited to hear what kinds of insights y'all have to share about it. It's a good one. And with that, I will stop torturing you now. And yeah, go out and be skeptical. Be tough on yourself. Be tough on others. That's the only way we're ever gonna grow and progress. Right? And don't believe the hype. All right, bye y'all. Take care.